Module 11 is about the entropy, the concept of entropy. The course outcome for this module is the ability to acquire and explain the basic concepts in thermodynamics, ability to apply and correlate the concept with the appropriate equations and principles to analyze and solve engineering problems. So by the end of the chapter, students should be able to define a new property called entropy to quantify the second law effects and explain the increase of entropy principle and calculate the entropy changes that take place during processes for pure substances, incompressible substances, and ideal gases. So we will the content of this module that we will cover is about the concept of entropy, the increase of entropy principle, and the entropy change of pure substances. So the concept of entropy is originated from Clausius inequality concept, which is this is a total of delta Q over temperature is similar or always lower than 0. So the equality holds for the reversible process and the inequality holds for the irreversible process, which leads to the new definition property called entropy. Okay, so remember, delta Q over temperature is lower than 0, is always lower than 0. So what does it mean by entropy? Entropy is a quantitative measure of microscopic disorder for a system, and microscopic disorder for a system, or is a measure of energy that is no longer available to perform useful work within the current environment. It's not available to perform useful work, but it is there. Okay, so ds is the entropy, so ds equals to delta Q over temperature in internal reversible. Okay, in kilojoule, the unit is kilojoule per Kelvin. So the extensive property unit in kilojoule per Kelvin, or intensive property unit in kilojoule per kilogram per Kelvin. Okay, so this is the diagram of the level of molecular disorder or entropy of a substance increases as it melts or evaporates. So as you can see from here, we have solid, from solid to liquid to gas. So this is from the changes of phases from solid, liquid to gas. The entropy will increase by the changes of the phases, or as you can say, as the temperature increase, the entropy also increase. Okay, so a pure crystalline substance at absolute 0 temperature is in perfect order, therefore and its entropy is 0. Okay, so this is the example. This is the third law of thermodynamics. Okay, disorganized energy does not create much useful effect, so no matter how large it is. Okay, these are the examples which related to the entropy. Okay, so in this situation, so you have shaft. Okay, we have some weight at here. In the absence of friction, raising a weight by a rotating shaft, okay, does not create any disorder, and thus energy is not degraded during this process. Okay, it's nothing. It's not involve entropy, and it doesn't involve entropy. In here, the pedal wheel work done on a gas. Okay, the pedal wheel done on the system which involve the gas increases the level of disorder or entropy of the gas. Therefore, and thus energy is degraded during this process. Okay, so it involves when the because of work have been done on the gas, so it will increase the level of disorder and the entropy of the gas. Therefore, the energy is degraded during this process. So this is the transfer process, transferation of heat from hot body to cold body from 80 degrees Celsius to 20 degrees Celsius. So what happened? What is the where is the entropy? How does it involve in this process? So during a heat transfer process, the net entropy increases, okay, between both of this body. So why? Because the increase in the entropy of the cold body, okay, is more than offsets the decrease in the entropy of a hot body. Okay, so this one entropy is increased. This one, for the hot body, the entropy is decreases. Okay, during this transferation of heat.